All right, welcome y'all. Miss Ridge here. Let's spend a little time discussing the nephron. Now that's going to be the topic for this week. The nephron is super important to understanding how the kidney works because it's what's called the functional unit, which is to say basically it's the place where it happens, where the kidney does the work of filtering the blood. You have hundreds of thousands of nephrons. They are very, very small. The kidney is absolutely full of them. Let's start. Before we focus on the details of how it works, let's make sure y'all are fresh on the parts. So at the start of our story, you're going to have the afferent arteriole and the efferent arteriole and the glomerulus. The afferent arteriole carries blood into the glomerulus. The efferent arteriole carries blood out. The glomerulus is our little ball of leaky capillaries here. That's where filtration is going to happen, but we'll get to that in a minute here. After the afferent and efferent arteriole, you also have another little blood vessel called the peritubular capillary. Its job is to be right up against the urine or the renal tubule, which is the place where all of the filtrate goes, and to reabsorb anything that went into the urine or the filtrate by mistake. You're also going to see the glomerular capsule, which is what initially captures the filtrate when it comes out of the blood and directs it into the renal tubule. And you're going to see the collecting duct, which is where the finished urine goes. So if we walk through those steps, in the afferent arteriole, efferent, glomerulus, and the peritubular capillaries, we have the blood that's being filtered. At the end of the story, in the collecting duct, you have the finished urine. But in the glomerular capsule and the renal tubule, in the middle, you have what we call filtrate, or you can think of it as pre-urine. It's not urine yet, but it will be soon. Some of what's in there will still get taken back by the body. A little more will be added. So let's break this process into its three main steps as we walk through it. So our blood comes in through the afferent arteriole. The glomerulus is leaky. There's blood pressure in there that forces some of that plasma in the blood out through those leaky capillaries in the glomerulus into what's called the glomerular capsule. That liquid being released is what we call filtration. So that takes place in the glomerulus. From there, it passes into the renal tubule, and this is where two important things happen. Thing one, what is called reabsorption. Reabsorption is about taking the stuff that went into the blood or into the urine by mistake and taking it back out and putting it back in the blood. So for example, you lose a lot of sugar this way that is not supposed to end up in the urine. It goes to waste. Your body will reabsorb it into the peritubular capillaries around this renal tubule to stop it from going to waste. Same thing happens with a lot of your excess water. The water gets squeezed straight out of the glomerulus like wringing out a rag. Most of it we're going to want back because you don't want to become dehydrated, which is what would happen if you didn't absorb a fair chunk of that back into your body. That said, though, there are some things that are too big to make it through those leaky capillaries in the glomerulus, but that still need to come out of your body. Some medications are like this. Those get kicked out during secretion, which goes the other way. That's more taking stuff out of the blood and putting it into the renal tubule. So reabsorption is stuff that we do want being pulled back into the blood. Secretion is some more stuff that we need to get rid of being pushed into the filtrate, into the urine, so that it can eventually leave your body. So filtration, reabsorption, secretion, and then in the end it gets collected by the collecting duct. Whatever is left in that finished urine gets carried off down the ureters to the bladder and out of your body. So if you need to play me back, if you need to listen to that again, that's absolutely fine. I encourage you to do that. We're going to take a look at some practice questions that have to do with some real drugs and hormones. We're going to talk about how they affect the nephron, and you're going to try to practice your understanding and answer some questions. All right, questions 1 and 2 are about caffeine. You're familiar with caffeine. You drink it in coffee or tea. Caffeine dilates the glomerulus, which makes it leakier. So if the glomerulus is leaking more, What will that cause to happen in the nephron? Think about what will move where, what will be different from usual, what does the glomerulus normally do? So take a second and answer question 1 now. Question 2, how will that change you just predicted affect the user's urine? Will it be more watery, more salty, less watery, less salty? Take a minute and answer that question now. Okay, so let's discuss the question you either did or did not just get right. So here's our glomerulus. Remember, the glomerulus is involved in filtration. It is leaky. We are making it leakier. That means that more water and more salt are going to escape out of the glomerulus into the renal tubule. And that means that eventually we're going to have more urine at the end. And if you have ever drunk a lot of caffeine, you may even have noticed this. It makes you pee more. Alcohol is the same way, by the way, for roughly the same reason. It's a diuretic. It makes you lose more liquid from your body. We've talked about diuretics before. It's a drug or a hormone that makes you pee. Okay. So, next questions. Furosemide or Lasix, this is a common blood pressure medication, works by preventing sodium from passing through the renal tubule. Remember, I said sodium is usually something that is involved in reabsorption, not secretion. So take a minute, think about it. If sodium is not participating in reabsorption, what will that cause to happen in the nephron? Take a minute and answer that now. Okay, so based on that, what will be different in the user's urine? Will there be more of it, less of it, saltier, less salty? Take a minute and answer now. Yeah, that one's a tricky one. So the reason that this is weird, first of all, if sodium is not participating normally in reabsorption, normally we want sodium to be soaked back up. It goes out of the filtrate and into the peritubular capillary. We are preventing that from happening. We're blocking that from passing between the filtrate and the peritubular capillary. So obviously, more salt is going to end up in the urine. However, there's a reason that this is weird, and I've talked about this a little bit before, and you may have seen it in your quizzes if you've been doing your quizzes, which you should be. Salt sucks. Wherever there is more salt, there will also be more water. So, high salt equals water is attracted. This is why Lasix is a blood pressure reduction medication. It takes the salt out of your blood, filters it out of your body, sends it out in your urine, so your urine will contain more salt, but the water will also go with it. And this causes your blood pressure to be reduced as well. Where water goes, salt will go too. The reverse. Where salt goes, water will go too. So those two are connected intimately to each other. All right, that was a tough one. Let's try one more. All right, last one. Aldosterone triggers the renal tubule to absorb more sodium. So more reabsorption of sodium is happening. It's the opposite of the question we just asked. How will that affect sodium levels in the body? Take a second and answer now. Okay. Given what I said about what salt does to your blood pressure, how will your blood pressure be affected by aldosterone in the body? Take a second, answer the question now. Okay. We'll take a look together. So we're doing the opposite of what we did last time. Rather than less salt passing from the renal tubule into that peritubular capillary, it's more. Lots and lots of salt is being pulled back into the body's arteries and veins. That means that more water is going to follow it, and so this person is going to end up with higher blood pressure than they would have otherwise. Now, that's not necessarily a bad thing. You don't want your blood pressure to be too low. That's a bad situation. That means you're not going to get enough oxygen to your brain. So we want some of that sodium to be absorbed back into the blood vessels in order to keep your blood pressure from falling too low. Hyponatremia, low blood sodium, can be a very serious condition and can even cause like serious neurological brain problems. So aldosterone is in balance. If it's not excessive in the body, a very good thing. Okay, let's take a quick look at some takeaways. Things that you definitely want to make sure you know before our quiz that's coming up at the end of this week. 1, make sure you know the parts of the nephron. 2, make sure you know what happens during filtration and reabsorption. You should probably know secretion too, but I didn't put it on your graphic organizer, so I won't quiz you on it because I'm nice. Finally, you should be able to tell me what effect sodium has on blood pressure. If you can tell me those 3 things, you're on a good track to do well on your quiz, which is due at the end of this week. All right. Hope this was helpful. If you have questions, please feel free to email, come to office hours, any and all of that good stuff. All right. Have a good day. Bye.